Greetings for the day. I am Kalpesh Raunda and topic allotted to me is reinforcement learning. So these are the points we will going to cover in this video. Starting with background and introduction. As there are three types of machine learning algorithms. First one is unsupervised learning. In this, machine is trained using information that is neither classified nor labeled and allow the algorithm to act on that information without guidance. As we have studied clustering algorithms that came into unsupervised category. The next one is supervised learning. It is basically we teach or train the machine using data that is well labeled. In this, there is a presence of supervisor or a teacher. The classification and regression techniques are supervised algorithms. And the third and very important topic of this discussion is reinforcement learning. Reinforcement learning, that is RL, is a type of machine learning in which an agent explores an environment to learn how to perform desired tasks by taking actions with good outcomes and avoiding actions with bad or negative outcomes. A reinforcement learning model will learn from its experience, and over the period of time it will be able to identify which actions will lead to the best rewards. Reinforcement learning has various applications like self-driving car image processing techniques. Now, there are some terminologies we need to understand first. First one is agent. Agent is a reinforcement algorithm that learns from trial and error. Agent can be person, thing, algorithm which perform actions. Environment is the world or surrounding through which the agent moves. Actions are the steps that agents can perform. Next is state. State is the current situation written by the environment. The rewards is an instance or feedback written from the environment to the last action. Next one is policy. Policy is the approach that agents use to determine next action based on the current state. Value. Value is the expected long-term return with discount and opposed to the short-term reward. Action value is similar as that of the value with an extra parameter, that is current action. Now, concept of reinforcement learning. The mathematical approach for mapping a solution in reinforcement learning is called Markov decision process. A Markov decision process, which is given in this diagram, this process tells us that the agent takes actions based on the current state in the environment, and environment sends reward to the agent. Reward can be positive or negative, and based on a reward, agent again perform actions. While taking actions, state may get changed. The series of actions taken by the agent defines the policy or defines the approach, and rewards collected that defines the value. So, main goal is here to maximum reward by choosing the optimal policy. Let us understand this with the shortest path problem. Our aim is to find shortest path between A to D and minimum with minimum possible cost. In this problem, the set of actions is to traverse from one node to another node. Set of states are denoted by A, B, C, D, that is nodes. Reward is the cost represented by each edge, that is cost required to traverse from A to C is 15, and policy is the path that we chosen to reach the destination. Let's say A to C, C to D is the one policy. Initially, the model will be blank. So, from node A, we will select node C with cost 15 instead of node B with cost 30. Then from node C, I have to go to node D. In order to get maximum reward, the policy gives the total reward of 65, which is more than any policy in the graph. The feature here we use is exploitation because we didn't explore any another nodes. The feature will be next in further slides. So next is the Q-learning algorithm. So what are the steps required to perform in the Q-learning algorithm? So first one is we have to set the gamma parameter. The gamma parameter has value ranges from 0 to 1 and the environment rewards in matrix R. Now then we have to initialize the matrix Q to 0. Then select a random initial state and then assign a initial state to the current state. Select one among all the possible actions for the current state. Using this possible action, consider going to the next state. Get maximum Q value for the next state based on all possible actions. Then we have to compute the Q matrix based on the R matrix and gamma value plus maximum of Q matrix. Then we have to repeat all these processes till the current state becomes the goal state, that is terminal state. Now the feature of reinforcement learning. The first one is reward maximization. This is the basic agenda of reinforcement learning. To reach maximization, the reinforcement learning agent must be trained in such a way that he takes best action so that the reward is maximum. Exploration. As the name suggests, exploring the environment and capturing the more information. On the other hand, exploitation is about using the already known exploited information to heighten the rewards, as we have discussed in the previous slide examples also. So now, what is the working principle of reinforcement learning? Reinforcement learning process starts when environment sends state to the agent. Then agent will take some actions based on the observation. In turn, then environment will send next state and respective reward. Agent will update his knowledge with reward returned by the environment, and it uses that to evaluate the previous action. So this loop keeps continuing until the environment sends the terminal state. So there are various applications of reinforcement learning. Here I have taken the example of PUBG game. Here the reinforcement learning agent is player and game platform will be the environment. So the agent collects state S0 from the environment. Based on the S0, the reinforcement learning agent takes initial action A0. The environment will be in new state S1 and reinforcement learning agent will get reward R1 from the environment. This loop continues till reinforcement learning agent is dead, or reinforcement learning agent, that is player, reaches the final state, that is terminal state. So this is the paper I have referred for the documentation of this video, and this is the one video also I have referred for the understanding the concept of reinforcement learning. Thank you.